Have you ever just looked up and wondered, why is the sky blue? And why do sunsets turn all those crazy shades of orange, red, and even purple? I mean, if the sky can change colors, why not green or pink at noon? Well, stick around, because we're diving into some mind-blowing physics without the boring textbook jargon. So let's get started. Alright, so here's the deal. Sunlight might look white to us, but it's actually a mix of all the colors of the rainbow. If you pass sunlight through a prism, you'll see it split into red, orange, yellow, green, blue, and violet, just like a rainbow. This happens because different colors have different wavelengths, and that's the key to everything we're about to discuss. Now, not all colors travel the same way through our atmosphere. Some scatter more, some less, and that's where the magic happens. When sunlight enters Earth's atmosphere, it hits tiny particles, mostly nitrogen and oxygen molecules. These particles scatter the light in all directions, but they don't treat every color equally. Shorter wavelengths, like blue and violet, scatter way more than longer wavelengths, like red and yellow. This effect is called Rayleigh scattering. It's the reason why we see blue light all around us during the day. But wait, if blue and violet scatter the most, why don't we see a violet sky? Even if you didn't bother to think that, I'll still tell you the answer. Actually, our eyes aren't great at detecting violet light, and plus, some of it gets absorbed by the upper atmosphere. So, what we mostly see is blue light bouncing around in every direction, painting the sky that familiar shade. Now, let's talk about the real magic sunsets. Ever noticed how the sky changes color as the sun goes down? That's because at sunset or sunrise, sunlight has to travel through way more atmosphere to reach your eyes. The extra air and dust particles scatter even more of the short wavelength colors. Blue and violet get scattered out of your line of sight. So, the longer wavelengths, red, orange, and yellow, make it through, giving us those fiery, dramatic skies. If there's a lot of dust, pollution, or even volcanic ash in the air, sunsets can get even more intense, sometimes even pink or deep red. Have you ever noticed how after wildfires or volcanic eruptions, sunsets look surreal? That's because of all the extra particles hanging in the air, ultimately scattering more light. The sky doesn't always look the same everywhere in the world. If you're in a city with lots of pollution, you might notice a slightly hazy or even yellowish tint during the day. That's because tiny particles from smog can alter the way light scatters. In places with really clear air like high-altitude locations or the middle of the ocean, the sky can look an even deeper, richer blue. And if you are planning to live in poles for some reason, then listen. During sunrise and sunset in the Arctic and Antarctic, the sky can stay red and orange for not some minutes, but hours. And it is because the sun moves much more slowly across the horizon, giving light an extended path through the atmosphere. Oh, and if you think Earth's sky is cool, check this out. On Mars, the sky is actually kinda opposite. During the day, it looks reddish because of all the fine dust in the air, but at sunset, it turns blue. And that's because Martian dust scatters red light more, allowing blue to sneak through. Pretty wild, right? On planets with thicker atmospheres, like Venus, the sky is a murky, yellowish white due to all the dense carbon dioxide and clouds of sulfuric acid. And on gas giants like Jupiter and Saturn, their skies are layered with different colors depending on altitude, from deep blues to hazy oranges. So, that's the reason why we get those jaw-dropping sunsets. If you enjoyed this breakdown, make sure to like, subscribe, and let me know what's your favorite sunset color.